Hi guys, so in this question, it is saying that you roll three independent fair 100-sided dice, which means there are three 100-sided dice which are fair and not biased, and yeah, they're 100-sided. So we are asked what is the expected value of the minimum of the three rolls. So when we roll three times, it is asked what is the minimum of the three rolls, and what is expected value of the minimum of the three rolls. So let's start with just a single die. So if we just had a single die of 100 side, the expected value, which is also the average value, would have been nothing but 1 plus 100 divided by 2, which came out to 50.5, which as the numbers are equally likely to go from 1 to 100. So it is just the average value. But here we are calculated we are asked to calculate the minimum of the three dice. Take the minimum of the three dice. So now we roll the three dice d1, d2, d3 and take the smallest result. This means that if any die rolls low, the minimum will be low. Only if all the dice roll high, we get a high minimum, right? Let's say we get we roll and we get 10, 30, 100. So say although 100 was also there, but our minimum is 100 is 10. So our answer will be 10. So that means uh, if only one dice gets the lowest one, then also our answer is the lowest one. So that increases our outcome of this question to be on a lower side, right? And to be lower than 50.5, the average. So now let's think in terms of probability. Here's a way to think about it. Chance that minimum is let's think about the chance that minimum is greater than k, greater than equals to k. That means chance that all three dice are greater than equals to k. As the minimum is greater than equals to k, that means the other dice too will have the numbers which are greater than equals to k, which in terms of probability can be thought of. Like, see, there were one, two, three, up to 100, right? And there was somewhere k in middle. So here these are k minus 1 opportunities, right? And we are missing out on these. We are only including these. So how much would these be? 100 minus k minus 1, which comes out to be 101 minus k. So let's include 101 minus k upon the total sample size 100. And this is only for dice 1. We have to do this for dice 2 and dice 3. So 101 minus k by 100, 101 minus k by 100. So this is a probability or a chance that minimum is greater than equals to k. So now, as we have to calculate the expected value, the average value, so we have to calculate E minimum, which will be its summation over its range. So k equals to 1 to 100, 101 minus k upon 100 whole cube. Now let's say 101 minus k equals to j, just for simplicity. The range will remain same. You can check that on your own. It won't change. But we'll get a simple expression of j cube upon 100 cube, which will be 100 cube, j equals to 1 to 100 j cube. And this is nothing else but the summation of first 100 natural numbers. So that will result in we know the formula for it, which is n into n plus 1 by 2 whole square. So 100 into 100 plus 1 divided by 2 whole square. And after calculating all these, which you can do on your own, it comes out to 25.05. And it is the answer. Hence, our expected value of the minimum will be this.